Hello there and welcome to the calm space of LUMIVERSE NL. Maybe it's been a long day, or maybe you're the kind of soul who finds peace beneath the quiet rhythm of distant worlds. Either way, tonight's story is for you. You don't need to move or think, only to breathe. Let your breath slow, your thoughts drift, and your body grow as light as the dust between stars. Because tonight, we will float gently through our solar system, a chain of worlds bound by sunlight and gravity. Not in a straight line, but in soft spirals, from the warm glow of the inner planets to the frozen silence of the outer ones. We won't hurry. We'll move the way light moves across the dark, slowly, continuously, endlessly. The sun burns quietly at the center, its light older than memory. Around it, the planets dance, tiny sparks in a vast gravitational field. Mercury, scorched and scarred, races closest to the fire. Venus, heavy with clouds, turns backward through its own golden mist. Earth, our home, breathes water and life. Mars, dry and waiting, remembers oceans that once whispered across its plains. Beyond them drift the giant worlds, Jupiter's storms rolling like ancient thunder, Saturn's rings glimmering with frozen light, and farther still, the cold blue twins, Uranus tipped sideways in its sleep, and Neptune spinning through winds that break the sound of silence. Beyond even that lies a faint frontier, where Pluto circles in twilight and comets wander between the stars. Each world tells a story written in stone, gas, or ice, all orbiting a single star that gives them meaning. This is not just astronomy. It's a slow conversation between time and motion. Every revolution, every rotation, is a heartbeat in the life of the solar system. So, as we begin, let the noise of your day dissolve. Let the rhythm of your breath match the rhythm of the planets. If this calm journey helps you unwind or dream a little deeper, consider joining this orbit by subscribing, or simply returning the next night to drift again. Because tonight, you are not on Earth. You are part of the system itself, adrift in a sea of light, carried by invisible currents of gravity. Far beyond the warmth of the inner worlds, a silent blue giant waits in the dark Neptune, the farthest known planet of our solar system. Here, sunlight is a faded whisper, a distant echo that takes over 4 hours to arrive. Yet even in this dimness, Neptune moves with astonishing power. Its winds are the fastest in the solar system, racing faster than the speed of sound on Earth. Imagine standing above those endless clouds, a world of frozen hydrogen, helium, and methane. Beneath the haze, storms twist like living shadows. The methane scatters blue light, giving Neptune its deep cobalt glow. These tempests spiral with unimaginable speed, driven not by sunlight, but by internal heat, still rising from the planet's heart, warmth left over from its birth billions of years ago. In those winds, faster than any storm on Earth, lies the paradox of Neptune, a frozen surface cloaked around a restless, burning core. Some astronomers believe that within its pressure-crushed depths, carbon atoms may fall as diamond rain, glittering as they descend through the twilight atmosphere. To drift through that world would be to sail through darkness and light at once, a silent ocean of blue storms, where the air itself becomes wind and crystal. Neptune's moons circle through this turbulence like patient guardians. The largest, Triton, orbits backward against the planet's rotation, a captured wanderer from the outer reaches of the Kuiper Belt. Its surface is pale and frozen, but beneath the crust, it may still breathe faint warmth, venting geysers of nitrogen into the void. Every orbit tells a story of capture and survival, of worlds pulled into balance by the invisible hand of gravity. And yet, Neptune is not alone in its solitude. Its faint rings drift like whispers, dusty arcs of frozen particles circling in fragile symmetry. They may not last forever. They may fade, just as Saturn's will. But for now, they remain thin halos of ice reflecting the faint light of a distant Sunday. So, as you drift through this far blue world, let the sound of your own breathing echo the movement of those winds. In every gust, there is rhythm. In every shadow, there is motion. The solar system is not still, it dreams through movement. If you're still awake, take a soft breath and imagine the wind that moves faster than sound. That is Neptune's lullaby, a storm that never ends, yet never breaks. From Neptune's dark storms, our journey bends inward toward the red deserts of Mars, the quiet planet that once may have breathed. For ages, it has shimmered in the night sky, a small ember of rusted light, watching over human dreams and myths. Yet beneath its frozen silence lies the memory of oceans, rivers, and storms that shaped its ancient skin. Stretching across its equator is a scar larger than any found on Earth. Valles Marineris, a canyon so vast it would span the entire width of North America, over 4,000 kilometers long and 7 kilometers deep. It cuts through the crust of Mars, like a wound that never healed. Scientists believe it was born not from rivers, but from the planet itself cracking apart as if the red world once groaned under its own restless heat. The sunlight that reaches Mars is soft, weaker than what touches Earth, but still enough to cast shadows across endless plains of dust. The air is thin, and the sky burns with a faded orange hue. Every stone, every dune, seems frozen in mid-breath, waiting for something that no longer comes. Yet the evidence is everywhere. Minerals, shaped by water, dried riverbeds twisting like veins, polar caps of carbon dioxide and ice that expand and shrink with the seasons. Mars is not dead, only sleeping. Its volcanoes stand as monuments to the heat that once pulsed through its heart. Olympus Mons, the tallest volcano in the solar system, rises nearly 22 kilometers high, 3 times taller than Mount Everest. So immense that its base could cover the state of New Mexico. It was built slowly by countless eruptions over millions of years. Because Mars lacks shifting tectonic plates, its volcanoes could erupt from the same spot again and again, stacking layers of rock until they pierced the thin Martian sky. Imagine standing at its summit, the horizon curving beneath you, the air so thin you could not hear your own voice. The sun would appear half the size it does on Earth, but still, it would gleam upon a landscape carved by ancient fire and ice. Dust storms wander across the plains like living ghosts, some growing large enough to cover the entire planet. They can last for weeks, turning daylight into red dusk, reshaping the surface with every whisper of wind. In 2018, one such storm swallowed the Opportunity rover, silencing it beneath a blanket of dust after 15 years of service. Even in death, the little machine remains there, a monument to human curiosity, asleep beneath an alien sky. But the storms always pass, the dust settles, and in the stillness that follows, Mars reveals its quiet truth, that it remembers rivers that once shimmered like glass, winds that sculpted its dunes, and a warmth that faded slowly over eons. It remembers the time when sunlight touched liquid water, when frost was rare, and when the thin air may have carried clouds instead of sand. Scientists now listen closely to these echoes. Probes trace the faint signatures of methane in the air, whispers that something might still stir below the surface. Frozen beneath the poles, hidden in the soil, could lie reservoirs of ancient water, sealed away like forgotten dreams. Mars may be silent, but it is not finished speaking. Each rock and ridge holds a syllable of a story older than Earth's continents. When you look up at the night sky and see that faint red light, you're not just seeing a planet. You're seeing the reflection of what Earth might have been, or what it could become. Mars stands as both a mirror and a memory, a promise and a warning. It tells us that warmth can fade, that oceans can dry, and that even silence carries history. So tonight, as your breathing slows, imagine that endless canyon stretching beneath a sky of bronze and dust. Let your mind drift across its plains, through the windless valleys, past the long shadows of frozen mountains. Somewhere beneath that stillness, something ancient waits, a heartbeat slow as stone, yet steady as time. Mars teaches us that even worlds without life can remember what life feels like. It is a museum of time, holding the echoes of water, warmth, and movement. Perhaps someday footsteps will cross its surface again, and the silence will finally answer back. For now, it sleeps wrapped in red dust and waiting for the dawn. From the scarlet deserts of Mars, our voyage turns toward a world wrapped in gold. Venus, the shrouded twin of Earth. At first glance, it seems familiar in size and shape, a sister world born from the same cosmic cradle, but beneath its bright clouds lies a planet transformed by fire, pressure, and silence. Venus glows softly in the sky, yet beneath that light lies one of the most hostile places in the solar system. Its thick atmosphere is composed almost entirely of carbon dioxide, cloaked in layers of sulfuric acid clouds. The air itself weighs upon the ground with a pressure 90 times stronger than Earth's, as if the entire weight of an ocean were pressing down from above. The surface temperature exceeds 460 degrees Celsius, hot enough to melt lead. Here, metals flow like wax, and no breeze can cool the endless heat. And yet, for all its fury, Venus moves with an eerie stillness. Its winds sweep the upper atmosphere at hurricane speeds, but on the surface, everything drifts in a slow-motion dream. The clouds reflect sunlight so efficiently that the planet glows brighter than any other in our night sky. Ancient civilizations called it both the morning and evening star, not realizing they were naming the same world, one that blazes with light while hiding a darkness below. Venus turns backward, spinning in retrograde rotation, opposite to almost every other planet. On this world, the sun rises in the west and sets in the east, and a single day lasts longer than its year. One rotation takes 243 Earth days, while its orbit around the sun takes only 225. That means, if you stood on the surface of Venus, you would see the sun crawl across the sky in reverse, a slow dance through a haze so thick it would appear as a dim glow rather than a blazing orb. Scientists believe Venus was once more like Earth, cooler, with oceans and perhaps even clouds of water vapor. But something changed. As the sun brightened and heat accumulated, water began to evaporate, feeding the greenhouse effect. Without oceans to store carbon, the planet spiraled into a runaway transformation. Today, its skies trap heat with relentless efficiency, creating a world of eternal daylight and endless storm. Even more mysterious is its silence. Unlike Earth, Venus has no global magnetic field to protect it from the solar wind. On our planet, molten iron moving in the outer core generates a magnetic shield, an invisible barrier that deflects radiation and preserves the atmosphere. But Venus's core seems sluggish, or possibly solid, lacking the energy to sustain such a dynamo. As a result, the solar wind has stripped away its lighter gases over time, leaving behind a thick, heavy blanket of carbon dioxide. The planet, once perhaps habitable, became a mirror of warning, a reflection of what happens when balance is lost. Still, even in that inferno, beauty remains. The clouds swirl in soft, creamy bands, illuminated by sunlight filtering through layers of acid haze. Lightning flashes silently inside the mist. Mountains rise beneath the clouds, one of them, Maxwell Montes, towers higher than Mount Everest, its peaks coated with metallic frost. Radar images from orbit reveal vast plains and ancient volcanoes, suggesting that the surface may still shift and breathe beneath the heat. When spacecraft first descended into its atmosphere, they survived only minutes before being crushed and melted. Yet during those brief moments, they sent back haunting images of orange skies, flat rocks, and a horizon blurred by dense air. The ground appeared smooth and strange, like a dream half submerged in fog. It was the last sight seen by those mechanical explorers before they fell silent forever. But their silence speaks volumes. It tells us that even in deathly heat, Venus remains a teacher. It shows what can happen when a planet's heart slows, when magnetic life fades, when sunlight becomes a trap instead of a blessing. Its story is not one of destruction, but of transformation, the evolution of a world that went too far into its own reflection. So as you rest tonight, imagine drifting above those golden clouds, where the air is gentle and the sunlight glows soft and orange. From that height, the storms seem calm, the heat a distant shimmer. Beneath you, the surface glows like a dying ember, beautiful, dangerous, eternal. Venus reminds us that not all light is gentle. Some brilliance burns too long. Some beauty hides a warning. And yet, there is peace in its stillness, a quiet equilibrium beneath the fire. It turns backward not in defiance, but in rhythm with its own timeless spin. If this calm exploration has carried you a little farther from your thoughts, take a slow breath. The next world awaits, cooler, quieter, but no less alive in its silence. Far beyond Venus's golden clouds, the solar system grows cold again. The sun fades to a bright star, and the light becomes fragile, the kind that doesn't warm but only illuminates. Out here lie two strange, silent giants, Uranus and Neptune, worlds of gas and ice that spin on the edge of darkness. Their pale blue light is the final echo of the sun's reach. Uranus moves like no other planet. Most worlds spin upright or with a slight tilt, but Uranus rolls through space on its side. Its axis is tilted by nearly 98 degrees, as if it were knocked over by an ancient collision. Because of this, it doesn't rotate like a spinning top. It tumbles like a rolling marble, its poles taking turns facing the sunday. For 42 years, one hemisphere basks in daylight while the other lies in shadow. Then, slowly, they trade places in a celestial rhythm that lasts longer than a human lifetime. Imagine standing near its atmosphere, though you could never truly stand. For there is no solid ground. Beneath the soft blue clouds lies a sea of methane, water, and ammonia, compressed into strange forms by immense pressure. The sunlight that touches Uranus is a whisper, yet its winds still move faster than Earth's hurricanes. In that calm emptiness, the air glows faintly turquoise, a world painted in the colors of silence. Deep below, temperatures and pressures may create something extraordinary. Scientists believe that within both Uranus and Neptune, carbon atoms are crushed until they crystallize, forming diamond rain that falls endlessly toward the core. Imagine it, storms of glittering gems drifting through darkness, each one born from pressure, falling through invisible oceans of hydrogen. In the coldest corners of the solar system, beauty takes the strangest forms. For a long time, Uranus was thought to be still and featureless, a quiet sphere drifting through the void. But modern telescopes reveal faint bands and storm systems hidden within its haze. These movements hint at a restless heart beneath the calm, a planet that, even after billions of years, still remembers motion. The same is true for Neptune, its distant sibling, whose deep blue atmosphere hides tempests of unimaginable power. Though both are called ice giants, they are not frozen in the way we think. Their cores are hot, their atmospheres alive. The cold we see is only their skin, masking the energy beneath. Like deep oceans on Earth, their layers shift, swirl, and flow in patterns too vast to see. It's a reminder that stillness is often an illusion. Even in places of endless winter, something always moves. And then there is the mystery of their rings, thin, faint bands of dust and ice circling their atmospheres like ghostly halos. Uranus has 13 known rings, dark and narrow, discovered only in 1977 when they briefly blocked the light of a distant star. They are sharp-edged and precise, sculpted by small shepherd moons that keep them in line. Neptune, too, wears its own subtle rings, broken and incomplete, drifting in arcs rather than full circles. They seem fragile, temporary, yet they have likely endured for millions of years, whispering through the dark. Orbiting Uranus are 27 moons, each one small, irregular, and shadowed. Some bear names from Shakespeare: Titania, Oberon, Miranda, as if the planet carries a quiet library of dreams. Miranda, in particular, is a world of broken cliffs and frozen scars, where canyons stretch 20 kilometers deep. It looks as if it has been torn apart and stitched back together, a reminder of how violent beauty can be. Neptune's largest moon, Triton, is another anomaly, a captured wanderer that moves backward around its planet. Its surface is so cold that nitrogen freezes solid, yet even here, there is activity. Cryovolcanoes erupt quietly, spraying icy plumes into space. Beneath its crust, there may be a hidden ocean warmed by the planet's gravitational pull. It's possible that even now, under kilometers of frozen nitrogen, liquid water flows in secret. Out here, sunlight cannot heat the air. What warms these distant giants is their own memory, the leftover energy of their formation, still slowly escaping after billions of years. Uranus and Neptune glow faintly in infrared light, their warmth invisible but real, like the last ember of a cosmic fire. To drift near them would be to float through stillness, where everything moves in slow spirals. The sunlight glitters faintly on the tops of their clouds, turning diamonds to dust and storms to shimmer. They are the quiet guardians of the solar system's edge, beautiful, remote, and endlessly patient. If you're still with me, take a moment to imagine those diamond rains falling forever in silence. Each one begins as pressure and ends as light, a transformation that mirrors the universe itself. Even in darkness, creation never stops. It only slows, waiting to be seen. And so, the journey continues inward again toward the living blue of Earth, where movement, warmth, and water find perfect balance. But before we return home, we must pass the gas giant whose gravity shapes them all. Jupiter, the king of storms. We leave the distant ice behind and fall slowly toward warmth, into the gravitational embrace of Earth, our living world. From space, it seems peaceful, a sphere of blue and white, wrapped in soft clouds that drift like breath across the surface. But beneath that calm exterior, Earth is alive. It shifts, cracks, and rebuilds itself in an endless rhythm of motion. Unlike any other known planet, Earth's crust is divided into vast tectonic plates, floating upon a sea of molten rock. These plates move at the pace of fingernails, just centimeters per year, but over millions of years, they have sculpted the continents, raised mountains, and built the landscapes that cradle life. Each quake and ridge, each ocean trench and volcano, is part of this slow, magnificent choreography. Without this motion, Earth would be silent. Carbon would not recycle. Oceans might stagnate. Climate would drift into extremes. The movement of the crust, its subduction, collision, and release, is what allows our atmosphere to breathe, our water to flow, and our life to persist. Beneath the surface, molten rock churns like blood through arteries, driven by heat escaping from the core. The planet is not still. It pulses. That pulse begins deep within the outer core, where molten iron spins around a solid center. This motion generates the magnetic field, an invisible shield that stretches far into space, protecting our atmosphere from the solar wind. Without it, the charged particles from the sun would strip the air away, just as they did to Mars. The field itself is alive, shifting, flipping, and drifting across time. Sometimes it weakens, sometimes it strengthens. Always, it moves like a heartbeat we cannot hear. This magnetic field creates auroras, curtains of green, violet, and red light that ripple near the poles. They are born from collisions between solar particles and atmospheric gases, glowing softly across the night. Every time the sky dances, it is the soundless signature of Earth's invisible shield. It's easy to forget that these lights, so calm and ethereal, are the product of violent energy, the same storms that rage across the surface of the Sunday. Above the crust, the continents drift. Beneath them, the mantle convects, and between them, life thrives in a fragile balance. When tectonic plates collide, they build mountain ranges, the Himalayas still rising higher each year. When they diverge, new seafloor forms, releasing heat and minerals into the ocean depths. And when they slide past each other, the world trembles for moments, releasing centuries of pressure in a single breath. Every tremor, every volcano, every mountain ridge is part of the same story. A world still forming, even after 4.5 billion years. Earth, in this way, is not finished. It is always becoming. Each sunrise, each quake, each tide is the continuation of creation. This process is rare. So far, no other planet shows clear evidence of active plate tectonics. Mars bears scars of fractures long frozen. Venus seems locked beneath a stagnant crust. Even the outer moons, though cracked and stretched by gravity, remain geologically young but motionless by comparison. Earth alone lives in constant geological renewal. It is this motion, this quiet restlessness, that may have made life possible. For billions of years, plate tectonics have recycled carbon dioxide through eruptions and erosion, regulating temperature and stabilizing the climate. When volcanoes exhale carbon, the air warms. When rain and rock absorb it again, the air cools. A slow, natural rhythm, the planet's own breath. Too much or too little, and the balance breaks. But for now, it holds steady, maintaining the delicate line between fire and frost, where life can bloom. The continents themselves are wanderers. Once joined in a single supercontinent called Pangaea, they have since drifted apart, scattering species and reshaping the flow of oceans. The Atlantic still widens, the Pacific still narrows, and deep beneath the crust, molten rock continues its patient circulation. Nothing on Earth is truly fixed, not even the ground beneath your feet. It's a humbling truth. We live upon moving stones, guided by forces we cannot see. Every mountain was once seabed. Every ocean floor will one day rise to sunlight again. The Earth turns, folds, and breathes, not as a static sphere, but as a living organism made of rock and fire. Next time you feel a tremor underfoot or see smoke rise from a distant volcano, remember it is not destruction, but renewal. It is the sound of the planet dreaming, rewriting itself one layer at a time. So take a breath. The air you draw in may once have passed through a volcano, a forest, a coral reef, a glacier, each one part of the same endless cycle. Everything on this world is connected by motion, and that motion never stops. The journey through Earth reminds us that life, like the planet, endures through transformation. Beneath our calm seas and quiet skies, a slow heartbeat of magma and magnetism continues to hum. In the darkness between Mars and Jupiter lies a realm of wanderers, a vast band of stone and silence known as the asteroid belt. It is not a crowded field of crashing rocks as old movies imagine, but a great emptiness scattered with fragments, worlds that almost were. Each one drifts in its lonely orbit, circling the sun as it has for billions of years, the remnants of a planet that never formed. If you could float there, you would see nothing for hours at a time, just black space and the faint shimmer of dust. The asteroids are separated by hundreds of thousands of kilometers, each following its own slow path. Yet together they form a ring, a cosmic scar between the inner and outer planets, where gravity once struggled and failed to bring unity. Jupiter's immense pull tore their formation apart before it could begin. What remains is a memory, millions of fragments frozen in quiet motion. Among them drift a few giants, Ceres, the largest of all, and Vesta, a bright relic shaped like a planet, but too small to hold an atmosphere. Ceres is so large that it is classified as both an asteroid and a dwarf planet. Nearly 950 kilometers across, beneath its dusty crust may lie a layer of briny water or mud, hints of internal heat that once stirred within. When NASA's Dawn spacecraft visited it, it discovered mysterious bright spots, reflective deposits of salt shining from deep craters. They are remnants of evaporated water, proof that even here, far from warmth, ice, and chemistry, once danced together in the dark. Vesta, its sister in orbit, is very different. Rocky, dense, and scarred by impacts so large they nearly split it apart. Its southern hemisphere is dominated by an enormous basin called Rhea Silvia, formed when a colossal object struck and shattered its crust. The impact sent fragments flying across space, and some of those pieces eventually fell to Earth as meteorites. Each one carries the texture of Vesta's history, a shard of a world that almost became a planet. Beyond these two lie millions of smaller bodies, most no larger than mountains. They are leftovers from creation, ancient as the sun itself. Some spin quickly, some tumble erratically, and some are not solid at all but rubble piles, loose clusters of stone held together only by gravity. When struck, they don't shatter like solid rock. They shift, absorbing impact like sponges of dust. Missions such as Hayabusa 2 and OSIRIS-REx have revealed this delicate nature, collecting samples and proving that these drifting stones are archives of the solar system's first moments. And yet, even among these ruins, there is companionship. Some asteroids have moons, tiny companions that orbit them in miniature dances of gravity. The first discovered was Dactyl, circling the asteroid Ida, captured in 1993 by the Galileo spacecraft. Since then, dozens more have been found. Some asteroids orbit each other in binary pairs, locked in eternal motion. In a universe of vast distances, even small bodies find ways to stay together. The asteroid belt is not the only home of these rocky nomads. Some wander closer to Earth, the near-Earth asteroids, silent travelers that cross our planet's orbital path. They are reminders that space is not static. It flows, exchanges, and evolves. Occasionally, one of these fragments is pulled into our atmosphere, blazing briefly as a meteor before dissolving into light. Others pass silently, unseen, continuing their journey through the deep. If you could listen closely here, you would hear nothing, not even the faint hum of air. But if silence had a rhythm, this is where it would live. The asteroids orbit like notes on an invisible staff, each with its own frequency, its own gravitational tone. Their paths are defined not by collision, but by harmony. Jupiter's gravity sculpts the pattern, creating gaps known as Kirkwood divisions where resonances sweep clear the space, ensuring that each rock finds its rightful place in the cosmic rhythm. It is a lesson in balance. Even in chaos, there is order. Even among debris, there is grace. These are not ruins of failure, but evidence of design, a reminder that not all creation needs completion to hold meaning. When you close your eyes tonight, imagine drifting between those ancient stones. Some are dark as coal, others glint with metal or frost. They move so slowly you might think they are still, but in truth, every one of them is falling forever, falling around the sun, never reaching, never stopping. Somewhere among them, a single grain of dust might have once struck another, fusing together the beginning of something new. Perhaps this is how all worlds begin, quietly, accidentally, in the silence between orbits. Our journey now passes beyond this sea of fragments toward a world of storms and giants, where gravity rules with unmatched strength. Ahead lies Jupiter, the king of planets, whose presence shaped everything you have seen so far. But before we reach its swirling clouds, take a breath. Let your mind rest among the drifting stones, the broken beginnings of worlds that could have been. We leave behind the fragments of forgotten worlds and fall into the realm of giants, where gravity bends everything toward power and beauty. Ahead rises Jupiter, the vast and ancient monarch of the solar system. It is so massive that it could swallow every other planet and still have room to spare. More than 11 Earths could fit across its diameter. It does not burn like a star, but it glows with its own internal heat, a remnant of its violent birth. From afar, Jupiter looks serene, a sphere of tan, gold, and amber bands swirling endlessly around its equator. But closer, those colors become chaos. Beneath the clouds lies a world without a solid surface, where storms have raged for centuries. The atmosphere is a deep ocean of hydrogen and helium, spinning faster near the equator and slower at the poles. Each layer moves independently, creating ribbons of wind that flow in opposite directions. A planet made entirely of motion. And there, in the southern hemisphere, an eye stares unblinking across time, the Great Red Spot. This storm has been raging for at least 350 years, possibly longer. Twice the width of Earth, it spins counterclockwise, surrounded by smaller tempests feeding its edge. Winds here reach over 400 kilometers per hour, and lightning bolts flash with the power to ignite cities. Yet, within that violence, there is order, a stable vortex that has outlived generations of humanity. If you were to descend into Jupiter's clouds, you would find no ground, no solid horizon. The deeper you fall, the denser the atmosphere becomes, until the pressure crushes metal and the heat rises beyond comprehension. Eventually, hydrogen itself changes form, turning into a strange metallic liquid that conducts electricity. It is this sea of metallic hydrogen that powers Jupiter's magnetic field, the strongest of any planet, extending millions of kilometers into space. That magnetic field traps particles from the sun, creating lethal radiation belts so intense they could destroy unprotected spacecraft in hours. Even Jupiter's moons are scarred by this invisible storm. Yet those same magnetic forces also create something sublime, the planet's own auroras, glowing at its poles with radiant light 1,000 times brighter than Earth's northern lights. They shimmer silently in ultraviolet wavelengths, invisible to human eyes but breathtaking to the instruments that can see them. Jupiter's gravity commands a kingdom. Surrounding it are over 90 moons, each a world in miniature. The four largest Io, Europa, Ganymede, and Callisto were first seen by Galileo in 1610, and they remain among the most fascinating places in the solar system. Io is the most volcanic world known. its surface covered in molten sulfur and rivers of fire. The constant pull and push from Jupiter's gravity stretch it like taffy, generating heat that fuels endless eruptions. Its plumes rise hundreds of kilometers high, painting the sky in yellow and orange haze. Io is chaos, but in its chaos lies energy, the heartbeat of the Jovian system. Europa, in contrast, is quiet and white, a smooth shell of ice covering a hidden ocean. Jupiter's pull flexes its interior, keeping the water beneath from freezing solid. Cracks and ridges spread across its surface like veins in glass, and some scientists believe that within that subsurface ocean, life may exist. Tiny organisms, perhaps, thriving in the warmth of hydrothermal vents, far from sunlight, but close to energy. Ganymede, larger than Mercury, holds its own magnetic field, the only moon known to do so. Its surface is ancient, scarred by ice and rock, a record of collisions and renewal. Some believe it too hides layers of water beneath its frozen crust. And then there is Callisto, a darker world, pitted with craters that have not changed for billions of years. If Europa and Ganymede are the future dynamic and alive, Callisto is memory, a preserved fossil of the early solar system. Together, these moons form a miniature planetary system, a reflection of the Sun's own design. Each moon shapes Jupiter's magnetic field, and Jupiter's gravity shapes them in return. It is a cosmic conversation, spoken through tides, energy, and orbit. Beyond the visible moons lie dozens more small, irregular satellites, some orbiting backward, some likely captured asteroids. They drift like loyal sentinels, guarding their massive parent from the empty dark. When Voyager and Galileo first photographed Jupiter up close, the images felt almost unreal. Swirling storms, golden clouds, lightning in the dark, a living canvas of gas and motion. But what those cameras saw was not chaos. It was harmony, a system in perfect dynamic balance. Jupiter does not destroy what surrounds it, it organizes it. Without its gravity, the inner planets might not have survived. The asteroid belt might have collapsed inward, striking the worlds we call home. In a way, Jupiter is the solar system's protector, the Great Shield, deflecting comets and asteroids that might otherwise find Earth. But it is also a reminder of scale. Our entire planet, with all its oceans and mountains, would be a mere pebble within its shadow. As you rest and listen, imagine drifting just above those endless clouds, watching lightning flicker beneath the haze. You cannot land, you cannot stand, you can only float, suspended in gravity and color. Each swirl of cloud is as large as continents. Each flash of light, a symphony of energy older than humankind. And in that vastness, there is peace, because in every storm there is rhythm, and in every orbit there is music. Beyond Jupiter's storms lies a realm of calm, beauty, and impermanence. The kingdom of Saturn, the jewel of the solar system. If Jupiter is power, Saturn is grace. Its pale golden light drifts softly through space, crowned by the most delicate and mesmerizing structure ever seen. The rings, vast and thin, glimmering like frozen halos of light. From a distance, Saturn appears almost perfect, a smooth sphere wrapped in gentle bands of color. But up close, its surface is chaos in disguise, roaring winds, lightning that flashes longer than any thunderstorm on Earth, and layers of clouds made of ammonia and ice. The planet spins so fast that it bulges at the equator, flattening slightly at the poles. Yet it holds its symmetry with elegance, like a dancer twirling within a storm. The rings, those shimmering arcs of silver and shadow, are not solid at all. They are made of trillions of particles, ranging from dust grains to house-sized boulders, each piece reflecting sunlight as it orbits. The entire system stretches more than 280,000 kilometers wide, but in most places is less than 100 meters thick, thinner than a single city block. From the right angle, they almost vanish, turning invisible against the darkness. Scientists believe the rings are young by cosmic standards, perhaps less than 100 million years old. They may have formed when a moon wandered too close and was torn apart by Saturn's gravity. Its icy remains spread into a thin sheet of debris. Over time, the fragments collided, smoothed, and arranged themselves into elegant layers. But even this perfection is temporary. Slowly, the rings are falling inward, a process called ring rain, as streams of icy particles spiral toward the planet, dissolving into its upper atmosphere. One day, the rings will fade, leaving only memory behind. And yet, in this impermanence, Saturn becomes even more beautiful, a symbol of cosmic balance, of creation and decay intertwined. What we see now is a fleeting masterpiece, a sculpture made of motion and light. Orbiting this giant are at least 83 moons, each with its own mystery. Some are small and irregular, drifting like debris. Others are vast enough to hold atmospheres and oceans beneath their icy crusts. The most famous of them all is Titan, a world that mirrors Earth in haunting ways. Titan is larger than the planet Mercury and wrapped in a dense orange haze. Beneath that haze lies a landscape of lakes, rivers, and seas, but not of water. Here, the rain is methane, and the lakes glisten with liquid hydrocarbons. Mountains rise from frozen ground, carved by flows of methane rivers that erode the terrain just as water shapes Earth. Above, the clouds gather and drift, releasing gentle storms that fall in slow motion through the thick air. To stand on Titan would be to witness alien familiarity. The gravity is soft, the horizon dim, the air tinted with gold. In the far distance, Saturn would loom enormous in the sky, its rings arching silently overhead like a second horizon. And beneath that glow, perhaps an ocean of liquid water lies hidden beneath the crust, warmed by heat from within. If so, Titan may be alive in secret, harboring the chemistry of life far from the Sunday. Saturn's smaller moons are no less enchanting. Enceladus, a world no larger than England, hides an ocean beneath its icy surface. From its south pole, geysers erupt, towering plumes of water vapor and ice shooting hundreds of kilometers into space. These jets feed Saturn's E-ring, connecting moon and planet in a shimmering exchange. Within the plumes, scientists have found organic molecules, salts, and signs of hydrothermal activity, the same ingredients that nurture life on Earth's ocean floors. Every orbit, every geyser, every shimmering ring particle is part of a single story, a network of gravity and time, weaving energy between world and moon. Saturn is not merely a planet, it is a system of harmony, its components in constant dialogue. When the Cassini spacecraft arrived there, it orbited for 13 years, tracing every curve of the rings, every shadow on the surface. Before it ended its mission, it dove between the rings and the planet, capturing the final whispers of this world. In its last moments, it sent back data through static, fading as it descended into Saturn's atmosphere. Cassini burned, but it became part of the planet it had loved, falling like a final snowflake into the golden clouds. Saturn, in its silence, teaches impermanence, that even the most beautiful things must eventually fade. The rings will fall, the storms will rest, but for now, they remain shimmering in sunlight, whispering in shadow, a song of frozen light that will echo for millions of years more. As you drift in thought tonight, imagine standing within those rings, surrounded by glittering fragments of ice and dust, each piece reflecting the same sunlight that warms Earth. You would not hear them move, but their orbits would hum through your body like music without sound. And if this journey through beauty brings you a sense of calm, share it, pass it to another soul who dreams beneath the same stars. Because the universe, like Saturn, is a gift that grows brighter when shared. The light of Saturn fades slowly behind us, its golden rings dissolving into distance. Ahead lies a smaller, quieter world, a scorched sphere of stone and silence, closest to the sun yet colder in mystery than many think. This is Mercury, the swiftest planet in the solar system, the first and last to greet the dawn. It races around the sun in just 88 Earth days, its orbit a perfect symbol of speed and solitude. Yet, despite its nearness to the star, Mercury is a world of extremes. Daytime temperatures soar above 430 degrees Celsius, hot enough to melt metal. But when night falls, a night that lasts 2 Earth months, the heat vanishes and the temperature drops to nearly minus 180 degrees. It is a planet of fire and frost, existing in sharp contrasts. Mercury's surface is ancient, scarred by countless impacts. Craters overlap like fingerprints of time, revealing a story of collisions and quiet endurance. The largest, Caloris Basin, stretches over 1,500 kilometers, a wound from an impact so powerful it rippled across the entire planet. The crust buckled, mountains rose, and valleys formed on the opposite side. Nothing has erased those marks since. There is no wind, no rain, no erosion, only silence and shadow. Unlike Earth, Mercury has no thick atmosphere to soften sunlight or scatter color. Instead, it possesses a ghostly exosphere, a whisper-thin shell of atoms blasted from its surface by the solar wind and micrometeoroid impacts. These particles, sodium, potassium, oxygen, bounce briefly through space before escaping into the void. The result is a shimmering, invisible veil that flickers faintly in ultraviolet light, like an echo of air that never was. And yet, within its desolation lies an unexpected secret. At Mercury's poles, hidden inside craters that never see sunlight, scientists have discovered water ice, bright, reflective patches preserved in permanent shadow. Temperatures in those deep basins remain cold enough for ice to survive for billions of years, shielded from the sun by crater walls. It is a paradox. Frozen water on the planet closest to fire. These icy deposits likely arrived long ago on the backs of comets or asteroids, carrying the same cosmic water that fills Earth's oceans. Even here, where no clouds form and no rain falls, the universe has left traces of its universal ingredient for life. Mercury also holds another mystery beneath its surface. Despite being small, only slightly larger than our moon, it has an unusually large metallic core, making up about 80% of its radius. That dense heart gives Mercury a magnetic field, weak but real, a faint echo of Earth's much stronger shield. Scientists believe its core may once have been larger still, before a massive collision stripped away much of its rocky mantle billions of years ago. What remains is the metallic survivor of a violent past, a planet reduced to its essence, the heart without the flesh. The surface itself tells the story of contraction. As Mercury's iron core cooled, it shrank, causing the crust to wrinkle and fold. Across the plains, enormous cliffs called lobate scarps stretch for hundreds of kilometers, the visible wrinkles of a planet growing smaller with age. It is a world literally folding in on itself, a reminder that even in space, time shapes all things. To look at Mercury is to see a fossil of creation, a world nearly untouched since the solar system began. Where Earth remakes itself and Mars erodes, Mercury endures. Its craters, its scars, its frozen shadows remain exactly as they were billions of years ago. Each one is a page from the solar system's first chapter, preserved in silence. When spacecraft like Messenger orbited Mercury, they mapped the planet in stunning detail, revealing ridges, plains, and metallic reflections where the sun glances off the ground. They discovered magnetic storms interacting with solar wind, creating faint auroral glows not in the sky, but across invisible boundaries of magnetism. Even here, so close to the sun, the planet hums quietly in electromagnetic rhythm. And the sun, always the sun, fills half the sky when seen from Mercury's surface. The light is relentless, the shadows sharp. Yet, without an atmosphere, there is no sky, only pure black space above a white-gold horizon. Day and night coexist here in contrast, one side scorched, the other frozen. It is a place of beginnings and endings, where time feels both eternal and immediate. If you could stand there, you would feel no wind, hear no sound. The only motion would be the slow drift of shadows as the sun rises and sets each cycle, lasting nearly 176 Earth days, a single day longer than its year. The ground beneath your feet would be older than any mountain, any sea, any sound you've ever known. You would be standing on memory itself. Mercury's story is one of endurance, the smallest planet, the nearest to the flame, and yet still intact after 4.5 billion years. It does not hold oceans or weather, but it holds something rarer, permanence. It is a witness, unchanging, to everything the sun has ever done. As you drift in thought, imagine the quiet of that world, a horizon where dawn comes in silence, where the stars vanish in brilliance, and where even heat becomes stillness. Mercury is the messenger, the first light and the last ember, forever running around the sun yet never burning away. In its emptiness, there is peace. In its stillness, truth. And in its endless motion, a reminder that even the smallest world carries the gravity of eternity. The sun is our constant, a star so familiar we forget its power. Yet, to truly understand our solar system, we must look at the heart that holds it all together. Every orbit, every beam of light, every breath we take comes from this single glowing sphere, a vast furnace where matter becomes energy and energy becomes life. The sun is not solid. It is a sphere of plasma, a storm of charged particles where hydrogen atoms collide and fuse into helium. In its core, temperatures exceed 15 million degrees Celsius. Here, gravity crushes atoms together, releasing light that will take hundreds of thousands of years to reach the surface. By the time it escapes, that light is ancient, older than human memory, yet new to the space beyond. When it finally reaches Earth, it has traveled 150 million kilometers, crossing the void in just over 8 minutes. Every second, the sun converts 4 million tons of its own mass into energy. That sacrifice, small compared to its immense body, fuels everything we know. The glow of dawn, the warmth on skin, the spark of photosynthesis, even the light reflected by distant moons, all of it began in that nuclear fire. And yet, the sun barely changes. For billions of years, it has burned steadily, perfectly balanced between the pull of gravity and the push of radiation. Its surface, called the photosphere, seethes with motion, bright granules of plasma rising and falling like boiling water, each the size of a continent. Above that layer lies the chromosphere, glowing red with heat, and beyond that, the corona, a halo of superheated gas that stretches millions of kilometers into space. Strangely, the corona is hotter than the surface over 1 million degrees, though no one fully understands why. Some believe that waves of magnetism rising from below energize the plasma, heating it from within. Others think tiny bursts called nanoflares scatter invisible fire through the air. The sun is a symphony of cycles. Every 11 years, its magnetic field reverses the north and south poles, swapping places. During this time, solar activity peaks, and dark sunspots bloom across its face. Each sunspot is a region of tangled magnetism, slightly cooler than its surroundings, but more energetic than anything on Earth. They give birth to solar flares, explosions of radiation that ripple through space at the speed of light. Sometimes, those flares are accompanied by coronal mass ejections, immense eruptions of charged particles that can travel millions of kilometers per hour. When they collide with Earth's magnetic field, they create shimmering auroras and, at times, disruptions in satellites and power grids. These storms remind us that we live within the sun's atmosphere, that even from across space, its weather reaches us. But there is more to the sun than heat and violence. It hums, literally. Pressure waves ripple through its body, causing it to vibrate like a musical instrument. These low-frequency oscillations, too deep for the human ear, are studied through a science called helioseismology. By measuring how those waves move, scientists can map the sun's inner structure, learning about the currents and magnetic flows beneath its surface. It's as if we could listen to the pulse of a star and hear its hidden heartbeat. Every movement within the sun shapes the solar system around it. Its gravity binds the planets. Its wind sculpts their atmospheres. Its light defines their days. The solar wind, a stream of charged particles flowing outward in all directions, stretches far beyond Pluto. It carves a protective bubble in space called the heliosphere, which shields the planets from cosmic radiation. Beyond that edge lies the heliopause, where the sun's influence finally fades, merging with the interstellar medium. Without the sun, there would be no time, no warmth, no color. Yet, for all its brilliance, it is finite. In about 5 billion years, it will exhaust the hydrogen in its core. It will expand into a red giant, swallowing Mercury and Venus, perhaps brushing against Earth's orbit. Then, as its outer layers drift away, it will collapse into a white dwarf, a faint ember of what once was still glowing, still holding light, but slowly cooling across eternity. That is the destiny of our star, and of all stars. Birth, balance, decay, an endless cycle that spans the universe. But for now, the sun remains in its prime, burning quietly, generously, steadily. It is the rhythm that governs everything, from the orbit of worlds to the ticking of a human heart. To stand beneath its warmth is to stand within a miracle. Every photon that touches your skin began as pressure and flame at the center of a star. Every breath of wind, every flicker of reflection, every spark of life is part of that same radiant gift. So tonight, as you rest, remember the quiet truth of light, that it was born from darkness, and that it never truly dies. It only transforms, traveling across space to find another world, another dawn, another dream. The sun gives, and in giving, it endures. Let its calm fire remind you that power need not roar. Sometimes it simply shines endlessly, silently, beautifully. Beyond the sun's radiant reach, far past the warmth that sustains our world, lie frozen realms of shadow and reflection. Among these silent bodies, one world stands out: Pluto, the distant wanderer once called the ninth planet. Though small and remote, Pluto captures imagination like few others. It drifts through twilight at the edge of the solar system, where sunlight is so faint that noon feels like eternal dusk. Discovered in 1930 by Clyde Tombaugh, Pluto remained a mystery for much of human history, a world glimpsed only as a point of light. But when the New Horizons spacecraft arrived in 2015, the fog of speculation cleared, revealing a place far stranger and more beautiful than anyone imagined. What it found was a landscape alive with ice, mountains, and slow-motion weather, not a frozen rock, but a world still in motion. Pluto is only about 2/3 the diameter of Earth's moon, yet its surface tells a complex story. Vast plains of nitrogen ice stretch across regions like Sputnik Planitia, a heart-shaped basin that became an instant symbol of this lonely world. Beneath that icy heart, scientists believe an ocean may still slosh in darkness, warmed by heat from radioactive elements and insulated by layers of frozen nitrogen and water ice. The heart's existence is more than poetic, it shapes Pluto's balance. The mass of the frozen basin slightly shifts the planet's rotation, locking it into gravitational resonance with its moon, Charon. The two bodies orbit a shared center of mass that lies outside Pluto's surface, meaning they technically revolve around each other, a binary world, forever dancing in equilibrium. From Pluto, Charon would appear enormous in the sky, a companion that never rises or sets. Their gravitational embrace has likely lasted billions of years. Charon itself is a world of deep canyons and frozen seas, scarred by ancient upheaval. Its surface bears reddish stains from organic molecules that drifted across from Pluto's atmosphere. Once, Charon may have had its own ocean, now long frozen beneath the crust. Together, Pluto and Charon form a kind of cosmic duet, one pale, one dark, bound by invisible harmony. Pluto's atmosphere, thin and fragile, is made mostly of nitrogen, with traces of methane and carbon monoxide. When it draws close to the sun, the warmth causes surface ices to sublimate, turning directly into gas and creating a delicate haze that stretches hundreds of kilometers into space. But as it moves farther away, the cold returns, and the atmosphere collapses, freezing back onto the ground like a frost. In this cycle of breathing and stillness, Pluto seems alive, inhaling and exhaling with every orbit. The mountains on Pluto are made of water ice, so hard and cold that it behaves like rock. Some peaks rise over 3,000 meters high, their slopes dusted with frozen methane that sparkles faintly in the dim sunlight. Across the plains, dark streaks of tholin complex organic compounds created by ultraviolet radiation color the ice in shades of red and brown. This mixture of chemistry and cold gives Pluto its soft pink hue, a tint both alien and strangely gentle. At its farthest distance, Pluto lies nearly 7.5 billion kilometers from the Sunday. The sunlight there is weak, just 1,000th of what reaches Earth. But even in that faint glow, the planet gleams a frozen mirror of creation, holding secrets from the earliest days of the solar system. Its orbit is elliptical, sometimes bringing it closer to the Sun than Neptune, but their paths never cross. Locked in a stable 3:2 resonance, Pluto completes 2 orbits for every 3 of Neptune's. This precise gravitational rhythm ensures they never collide, a cosmic dance written into the fabric of space itself. When New Horizons passed by, it measured Pluto's surface temperature at around -230 degrees Celsius. The spacecraft's instruments also detected a surprisingly active geology, glaciers flowing across the plains, cracks in the crust that hint at internal motion, and haze layers stacked in the atmosphere like gauze. It was a revelation, proof that even at the solar system's edge, energy still stirs beneath the cold. And perhaps that is Pluto's greatest lesson. That distance does not mean death. Even so far from sunlight, warmth endures. Beneath kilometers of ice, water may still move. Above, faint winds lift dust and frost. Light from the sun takes over 5 hours to reach it, and yet it still shines. Pluto is the frontier, the dream of the solar system. It reminds us that even in the coldest corners of creation, beauty endures, patient and perfect. We once called it a planet, then a dwarf, but perhaps it is something greater, a symbol of how even the smallest things can carry infinite wonder. So, Let your thoughts drift outward to that faint glimmer at the edge of sunlight. Imagine the frozen heart that still beats there, unseen but unforgotten. For as long as it circles the sun, Pluto will keep time with the rhythm of the cosmos, distant, slow, and eternal. As we drift closer to the warmth of the inner solar system again, we encounter a planet that reflects Earth's restlessness yet carries the silence of a world long asleep. Mars, the Red Wanderer. We have glimpsed its canyons and volcanoes from orbit, but few realize just how immense and ancient its features truly are. To understand Mars is to see the memory of a living planet frozen in time. Stretching across its equator lies a scar so vast that it defies imagination. Valles Marineris, a canyon system 4,000 kilometers long and up to 7 kilometers deep, it would span the entire width of North America, cutting through the crust like a wound left by the planet's own formation. Unlike the canyons of Earth, carved by water and erosion, this chasm likely formed as Mars's crust cracked under tension, pulled apart as the surface cooled and shifted. Later, wind and landslides widened it, sculpting the colossal labyrinth we see today. If you could stand at its edge, the horizon would curve away before your eyes, the walls vanishing into a red haze that never ends. Beyond this scar, to the northwest, rises a mountain so large it almost defies the concept of a mountain at all. Olympus Mons, the tallest volcano in the solar system, towers nearly 22 kilometers high, 3 times the height of Everest, and its base spans an area the size of France. It is a shield volcano, built not by violent eruptions but by the slow, persistent outpouring of lava over millions of years. On Earth, tectonic motion shifts volcanic hotspots, creating chains of islands. But on Mars, where the crust stands still, eruptions stack atop one another, layer by layer, until a single massive dome pierces the sky. If you stood atop Olympus Mons, the horizon would stretch hundreds of kilometers in every direction, curving visibly with the planet's roundness. The air would be thin, almost non-existent, and the sun would appear only half the size it does on Earth, yet the view would be eternal. A vast desert painted in orange and gold, stretching from the base of the mountain to the line of the horizon. Mars is a planet of contradictions, shaped by fire yet dominated by dust, frozen yet filled with the marks of ancient rivers. Dry valleys twist through its crust like veins, their courses long, empty but unmistakably carved by flowing water. Minerals found in its rocks tell the same story, that once Mars had oceans, perhaps shallow but widespread, covering much of its northern hemisphere. The planet's tilt and orbit create seasons, just as on Earth, though colder, slower, and longer. At the poles, layers of ice and dust record these cycles like rings of a cosmic tree. During winter, the polar caps expand, cloaked in dry ice, frozen carbon dioxide that sublimates back into gas each spring, feeding thin winds that whisper across the planet. Those winds shape dunes, carve ridges, and carry the fine red dust that coats everything. Sometimes they rise together into storms so vast they encircle the planet, shrouding it in a dim copper glow for weeks or months. In 2018, one such storm brought an end to the Opportunity rover's long mission. For nearly 15 years, it had roamed the surface, exploring craters and plains. But as the sky darkened and sunlight vanished, its solar panels could no longer breathe. It sent its last message: "My battery is low, and it's getting dark." Then, silence. Even now, that small rover rests beneath the dust, preserved by the world it came to study. Mars's surface may appear desolate, but beneath its crust lies mystery. There are hints of liquid water locked beneath the ice at its poles, and possible underground reservoirs near the equator. Methane gas has been detected in the atmosphere, fleeting, changing with the seasons, suggesting something active below. perhaps geological, perhaps even biological. If life ever existed on Mars, it may not be gone. It may simply be waiting in the dark, under layers of rock and time. Its volcanoes, though long dormant, remind us that the planet once pulsed with internal heat. Tectonic forces stretched and reshaped its crust, creating fault lines and valleys. Some scientists believe that Mars once had a molten core strong enough to generate a magnetic field, much like Earth's, but it cooled too quickly. Without that magnetic shield, solar winds stripped away its atmosphere, leaving it exposed and fragile. Oceans evaporated, rivers vanished, and a temperate world became a desert. As you rest tonight, picture yourself drifting over its surface past the Great Canyon's shadows, across the frozen poles, over volcanoes taller than imagination. Below you lies a world that once knew warmth, water, and motion, now preserved in red dust. Mars waits, patient as ever, a silent promise that life in some form, somewhere always finds a way. And beyond it, further still, another world spins in darkness. Vast and blue, a planet of storms and moons, where gravity reigns supreme. Jupiter awaits our return, its clouds already turning beneath the eternal light. Beyond the red deserts of Mars, we return once more to a realm of giants, to the planet that holds the solar system's greatest storms, deepest magnetism, and most mysterious beauty. This is Jupiter, the king of planets, and yet even its grandeur cannot prepare the mind for what follows. Its system of rings, faint and ghostly, and the moons that dance like glowing embers around it. We often imagine Saturn as the only planet with rings, but Jupiter has them too delicate, dim, and almost invisible. Discovered by the Voyager 1 spacecraft in 1979, they are made mostly of dark dust ejected from its small inner moons. Unlike Saturn's icy halos, these rings do not shine. They absorb light, glowing only faintly in the backscatter of the Sunday. They form a structure so thin that, from most angles, they vanish into the background of space. The main ring lies close to the planet, shaped by the gravity of two small moons, Adrastea and Metis, that orbit just beyond its edge. Beyond that lies a faint, wide halo of dust, called the Gossamer Rings, formed from the debris of Amalthea and Thebe. Each grain of dust is pulled, shaped, and ultimately lost to Jupiter's gravity, drifting downward like invisible rain. It is a system of impermanence, fragile and transient, renewed only by the steady erosion of its moons. When sunlight strikes these faint rings, they shimmer like a phantom crown. To an observer near Jupiter, they would appear not as solid bands, but as drifting veils of smoke, almost transparent, yet structured by rhythm and resonance. They are a whisper of the forces that rule this vast world: gravity, motion, decay, and renewal. And around Jupiter itself, that power manifests in full. Its atmosphere is a rolling canvas of bands and vortices, each a jet stream moving in the opposite direction of its neighbors. The cloud tops, made of ammonia and water crystals, are streaked with colors of ochre, cream, and red patterns sculpted by wind and lightning. The Great Red Spot, a storm older than any empire, still spins after centuries, shrinking slightly each decade, yet refusing to fade. Nearby, smaller tempests form and dissolve like living things, part of the planet's endless dance of energy. Lightning flashes deep within the clouds, bolts hundreds of kilometers long, illuminating the layers below for an instant. Thunder does not follow. There is no air to carry it. Instead, the light vanishes back into shadow, and the storm continues, patient and eternal. To circle Jupiter is to witness scale beyond comprehension. Its magnetic field extends millions of kilometers, the largest structure in the solar system. Inside it, Charged particles whirl at near light speed, trapped by invisible lines of force. The radiation here is deadly, a sea of energy powerful enough to destroy unshielded electronics within minutes. Yet, within this same domain, dozens of moons orbit unharmed, locked in gravitational precision. Among them is the fragile world of Io, its surface blistered with sulfur and molten rock. Constantly pulled and flexed by Jupiter's immense gravity, Io releases heat through hundreds of volcanoes. Each eruption spews plumes of gas that rise hundreds of kilometers before falling again like ash. The material forms a thin torus around the planet, a glowing ring of charged sulfur ions that interacts with Jupiter's magnetosphere. A visible connection between Moon and Master. A little farther out glides Europa, its icy crust etched with dark lines and fractures. Beneath its frozen skin lies a global ocean of water, warmed by tidal heating. The gravity of Jupiter and its neighboring moons stretches Europa's core with each orbit, generating enough friction to keep its hidden sea liquid. This balance between gravity and warmth makes Europa one of the most promising places for life beyond Earth. Perhaps, deep below the ice, near volcanic vents on its seafloor, simple organisms drift in the dark, nourished by chemistry rather than sunlight. Beyond Europa lies Ganymede, the largest moon in the solar system, even bigger than Mercury. It, too, has an internal ocean, layered between ice sheets, and possesses its own magnetic field, the only moon known to do so. Farther still, Callisto orbits in silence, heavily cratered and ancient, its surface unchanging for billions of years. These four moons, Io, Europa, Ganymede, and Callisto, form a miniature solar system of their own, echoing the structure of the one we know: volcanic chaos, oceanic mystery, dynamic energy, and frozen memory. To see them together is to understand the architecture of motion, how gravity organizes even chaos into harmony. Each orbit resonates with the others, locking their periods into mathematical ratios, a celestial symphony conducted by Jupiter's mass. When the Juno spacecraft arrived in 2016, it plunged into polar orbit and revealed the planet's secrets in detail never seen before. It discovered cyclones the size of continents swirling around the poles in perfect geometric patterns, hexagons, pentagons, rings of rotating storms nested like fractals. It mapped the deep roots of the Great Red Spot, found layers of ammonia, snow, and water vapor, and measured the hum of the magnetic field itself, a soundless vibration that echoes across plasma and time. Jupiter, it turns out, does not simply orbit the Sunday. It protects everything else around it. Its immense gravity captures asteroids, redirects comets, and stabilizes the inner solar system. Without it, the small, fragile worlds, including our own, might have faced constant bombardment. It is both guardian and destroyer, its presence shaping the orbits of everything that exists nearby. And so, though we call it a planet, Jupiter is more like a sun that never ignited, a failed star whose mass was just shy of the threshold for nuclear fusion. Had it been only 80 times heavier, it would have burned with its own light. Instead, it glows faintly from the warmth of its creation, the afterglow of compression and gravity. As you rest tonight, picture that vast world turning slowly in space, storms the size of continents drifting across its face, moons circling like sparks of light, and faint rings glimmering at its edges. Jupiter is both chaos and calm, fury and order, the embodiment of balance within power. Let its endless rotation remind you that strength can be quiet, that protection can exist without sound, and that even the mightiest forces in the universe move with grace. Beyond the colossal storms of Jupiter and the golden silence of Saturn lies a reminder of where we began: Earth, the only world we know that breathes. Seen from space, It appears small, fragile, radiant. But beneath that calm swirl of blue and white lies complexity beyond measure. The only place where matter has learned to think, to feel, to dream of the stars that created it. Earth's uniqueness does not come from its beauty, but from its balance. It floats within the perfect distance from the sun, not too hot, not too cold, where water can exist in all three states: solid, liquid, and vapor. Ice at the poles, oceans that shimmer with life, clouds that drift and rain that falls. It is this delicate equilibrium that sustains everything we know. At the planet's heart, more than 5,000 kilometers below our feet, lies a molten core, an engine of fire and iron. The outer layer of that core spins around a solid center, generating a magnetic field that extends far beyond the atmosphere. This invisible shield deflects solar winds, trapping charged particles in belts that encircle the planet. Without it, radiation would strip away the air, the seas, and everything alive. The field is not constant. It drifts and fluctuates, sometimes reversing entirely. Yet it endures, preserving the thin veil of life that clings to Earth's surface. That surface is always moving. Massive tectonic plates slide slowly across the mantle, colliding and parting, building mountains and tearing continents apart. They recycle carbon, sculpt landscapes, and balance the planet's climate over geologic time. When volcanoes erupt, they exhale ancient gases back into the air, the same molecules that once nurtured the first oceans. When the plates dive beneath one another, they bury carbon deep underground, cooling the world again. Every eruption and quake, every ridge and trench, is part of a single, slow respiration, the breath of the planet itself. From space, the planet glows faintly blue, the color of Rayleigh scattering, as sunlight breaks and bends through air and ocean. The continents drift like islands of memory. Lightning flashes through storms, illuminating the atmosphere with brief, silent fire. Above it all, the auroras shimmer near the poles, waves of green, red, and violet light rippling through the night. They are the visible signature of our magnetic shield, the breath of the sun meeting the skin of the earth. The oceans, which cover 70% of the surface, are the planet's memory. They store heat, move currents, and cradle the earliest forms of life. Beneath their depths, hydrothermal vents spew mineral-rich water from the crust, forming entire ecosystems that live without sunlight, relying instead on chemistry and heat. These vents may echo the first conditions of creation, where molecules once combined to form life itself. Above the oceans, the atmosphere cycles water endlessly. Evaporation, condensation, rainfall, the rhythm of renewal. Each drop that falls has traveled through countless clouds, rivers, and seas over millions of years. The water in your veins once flowed through glaciers, volcanoes, and perhaps even the clouds of a younger world. Earth's diversity of species, landscapes, and climates is the product of billions of years of experimentation. From single-celled organisms to forests, coral reefs, and deserts, life has reshaped the planet, carving oxygen from stone and transforming carbon into growth. The biosphere and the planet are one, an evolving partnership of rock and life, fire and breath. In the silence of space, Earth hums. Seismic waves resonate through its crust. Oceans move in tides pulled by the moon's gravity. Winds circulate, transferring heat from equator to pole. Even the planet's magnetic field oscillates in rhythm with the solar wind. Everything, from continents to clouds, participates in this global symphony, a harmony of motion, energy, and time. If you could listen from orbit, you would hear nothing, but if your ears could hear in frequencies of vibration and motion, the Earth would sing. It would be a note of deep resonance, a vibration that has not stopped since the world's beginning. Sometimes we forget how rare this balance is. Mars is too cold, Venus too hot, Mercury too bare, and the outer worlds too distant. Only here, within this fragile envelope of air and light, has the universe created a place soft enough for thought. So as you breathe now, remember that you are part of that rhythm. The air in your lungs once moved through leaves, oceans, and storms. You are not separate from Earth. You are one of its expressions, a voice it uses to understand itself. Let that thought settle with the calm of gravity, the warmth of sunlight, and the silence between waves. The planet does not demand worship. Only awareness, a recognition that everything you are is born of everything it is. If Earth is the melody of life, then the sun is the instrument that plays it steady, radiant, eternal in its rhythm. Yet even the sun, so constant to our eyes, is not still. It breathes in light and sound, vibrating through space like a vast, living chord. Scientists have learned that the sun, our nearest star, actually sings, though not in any frequency we can hear. Its voice is a language of pressure and motion, a cosmic heartbeat rippling through plasma and time. This phenomenon is called helioseismology, the study of waves that travel through the sun's body. Just as geologists use earthquakes to probe Earth's interior, astronomers use these vibrations to map the sun's hidden layers. Each oscillation moves the surface by a few dozen meters, but when millions occur at once, they create a standing wave that can last for days. The sun's tone is deep and continuous, far below the threshold of human hearing, a frequency more felt than heard. If we could translate it, the sun's sound would resemble the hum of countless overlapping bells, shifting as its magnetic fields twist and coil. Every cycle of this sound tells us something about the star's inner life, how plasma moves, how heat rises, how gravity balances the endless expansion of fusion. Beneath the quiet glow we see, the sun is a restless sea. Its surface, the photosphere, ripples with convection cells, each the size of continents, bubbling up and sinking again like boiling honey. Above that lies the chromosphere, glowing red with energy, and beyond it, the corona, a halo of gas hotter than the surface itself. From this crown, streams of charged particles, the solar wind, flow outward, touching every planet, every moon, every grain of dust in the solar system. That gentle wind is the thread that connects us all. Every 11 years, the sun's magnetic field flips, reversing its poles. During this period, the surface darkens with sunspots, cooler regions where magnetic energy bursts outward. These spots are not still. They churn and release immense flares of light, solar flares that travel across the void at near light speed. When aimed toward Earth, these flares collide with our magnetic field, creating auroras that shimmer like curtains of fire in the upper atmosphere. Sometimes, the sun's activity peaks in a violent surge. Entire sections of its atmosphere can erupt outward in coronal mass ejections, colossal clouds of plasma hurled into space. If one were to strike Earth directly, it could disrupt satellites, radio networks, even power grids. Yet, these same outbursts also seed the cosmos with energy, dust, and magnetism. They are both destructive and creative reminders that every gift of light comes with shadow. For all its fire, the sun is remarkably stable. It has burned for over 4.6 billion years and will continue for billions more. In its core, nuclear fusion converts hydrogen into helium, releasing energy that radiates outward. That light spends hundreds of thousands of years bouncing through dense plasma before escaping the surface. Then, only 8 minutes more to reach Earth. When sunlight touches your skin, you are feeling energy that began its journey before humanity existed. It is humbling to think that every color, Every warmth, every shadow owes its existence to those ancient photons. They illuminate oceans, power storms, and sustain forests, and when they fade into night, they still linger as warmth in the soil, motion in the wind, or reflection in the moon's glow. The sun's influence does not end when the day does. It lives within every breath, every wave, every pulse. Yet, for all its grandeur, the sun is mortal. In about 5 billion years, it will begin to change. When its hydrogen fuel runs low, the balance between gravity and radiation will collapse. The core will contract, and the outer layers will expand, turning the sun into a red giant. It will grow so vast that Mercury and Venus will be swallowed, and Earth may be scorched into vapor. For a time, the solar system will blaze brighter than ever before, a final act of beauty before decline. Then, the outer layers will drift away, forming a planetary nebula, a glowing shell of gas expanding into the dark. At the center will remain the core, dense, white, and small. A white dwarf, about the size of Earth but containing half the sun's mass. It will no longer shine by fusion, but by the heat of memory, slowly cooling over trillions of years until it becomes a black dwarf, invisible but eternal. As you close your eyes tonight, imagine that quiet hum echoing across time, the sound of a star's heartbeat. Feel its warmth not as fire, but as connection, the bond between light and life, between the infinite and the fragile. Every dawn is the universe remembering itself, and every night is its pause to breathe. The sun burns, not in rage, but in devotion, a ceaseless offering of energy and time. And through that offering, we exist. As the sun continues to burn with steady brilliance, its light reaches the second planet, a world that glows like a morning star, yet hides an inferno beneath its golden veil. This is Venus, often called Earth's twin, but in truth, it is a reflection of what happens when balance slips, when warmth becomes imprisonment, and beauty becomes isolation. Venus is almost the same size and composition as Earth, but it could not be more different. Beneath its bright clouds, the surface burns at over 460 degrees Celsius, hot enough to melt lead. The atmosphere is a crushing blanket of carbon dioxide, nearly 100 times thicker than Earth's, with winds that howl at hurricane speed across the upper layers. Yet near the surface, the air is nearly still, heavy as stone. Lightning flickers silently through the sulfuric acid clouds, illuminating a world where no sound escapes. For centuries, Venus was seen as a symbol of love and beauty, the brightest object in the night sky after the moon. But when the first spacecraft descended through its atmosphere, they discovered a realm more hellish than heavenly. In 1970, the Venera probes from the Soviet Union touched the surface, transmitting the first and only photographs from below the clouds. The images revealed flat plains, scattered with stones, and an orange horizon blurred by thick haze. The probes lasted only minutes before melting, their final transmissions distorted by the weight of the air. Why did Venus become this way? The answer lies in runaway greenhouse effect, a feedback loop that spiraled out of control. Long ago, Venus may have had oceans, clouds, and rainfall, much like Earth. But as the sun's heat intensified, its water began to evaporate. Water vapor is a potent greenhouse gas, and as it increased, the atmosphere trapped even more heat. The oceans boiled away, the carbon dioxide once locked in rocks was released, and within a few million years, the planet transformed into a furnace. Today, the pressure at Venus's surface is equivalent to being nearly a kilometer under Earth's oceans. There is no escape from its heat, no shelter from its air. Even the night side, forever hidden from the sun for months at a time, remains just as hot. The thick atmosphere circulates heat so efficiently that the entire planet bakes evenly. And yet, Amid this chaos, there are hints of mystery. Venus spins backward, in what astronomers call retrograde rotation. While most planets, including Earth, rotate from west to east, Venus turns the other way, taking 243 Earth days to complete one rotation longer than its entire year, which lasts only 225 days. To stand there, if one could survive it, would mean seeing the sun rise in the west and set in the east, moving slowly across the sky in a dim, perpetual twilight. This reversed rotation likely began with a cataclysm, a massive collision early in Venus's history that altered its spin. Or perhaps tidal interactions with the sun slowly slowed and flipped the planet over billions of years. Whatever the cause, it gave Venus a rhythm unlike any other world. A slow dance, graceful and strange, in defiance of cosmic convention. Venus also lacks a magnetic field, an absence that speaks volumes. On Earth, our magnetic shield is powered by the churning of molten iron in our core, generating a protective barrier against solar radiation. Venus, however, seems to have a sluggish or solid core, unable to sustain the same dynamo effect. Without this shield, the solar wind stripped away its lighter elements, leaving behind only heavy gases that suffocate instead of sustain. But there is beauty in its tragedy. From orbit, Venus is mesmerizing, a pearl wrapped in swirling clouds, reflecting sunlight with dazzling brightness. Its upper atmosphere, though deadly below, may harbor zones where conditions are surprisingly mild. About 50 kilometers above the surface, temperatures and pressures resemble those of Earth, and scientists speculate that microbial life could drift there, suspended in the thick haze. In recent years, traces of phosphine gas have been detected, a possible biosignature that has sparked both debate and wonder. Could life exist in the clouds of a planet once lost to fire? It remains one of astronomy's most haunting questions. Venus's mountains and plains tell stories of violence and rebirth. Radar imaging has revealed volcanic structures larger than anything on Earth, some still warm, suggesting activity even now. Vast plateaus, called tesserae, rise from the plains, their surfaces folded like ancient parchment. The crust appears to have melted and re-solidified many times, erasing much of its geological record. The planet, it seems, occasionally renews itself not through gentle erosion, but through catastrophic resurfacing. Venus reminds us that beauty can endure in any form, even in ruin, even in silence, even in the quiet turning of a world that spins the wrong way but still shines. Far beyond the warmth of Venus and the storms of Jupiter lies a collection of worlds that shimmer like lanterns in the dark the moons of our solar system. Though small compared to their parent planets, they hold some of the most breathtaking mysteries in existence. Each one is a world in its own right, carrying oceans, mountains, ice, and history within its orbit. Together, they form a celestial archive of the universe's memory. There are more than 200 known moons, and new ones are discovered every few years. Most orbit the giant planets. Jupiter and Saturn alone claim more than half of them. But even the smaller worlds, like Pluto, carry companions of their own. Some moons are ancient and cratered, others are geologically alive, reshaping themselves even now. And among these distant satellites, there are a few so extraordinary that they could one day redefine what we call habitable. Right? We begin with Europa, the frozen ocean moon of Jupiter. Its smooth, pale surface glistens with ice, crisscrossed by dark streaks and fractures. These lines are scars from Jupiter's gravity, which stretches Europa's interior and keeps it warm through tidal heating. Beneath the crust, hidden under kilometers of ice, lies a global ocean, perhaps twice the volume of all of Earth's combined seas. It may be salty, rich with minerals, and warmed by hydrothermal vents at its seafloor. There, in total darkness, the ingredients for life might stir not life as we know it, but something ancient, slow, and enduring. Then there is Enceladus, one of Saturn's smallest moons, no larger than England, and yet it hides one of the most powerful secrets in the solar system. In 2005, the Cassini spacecraft discovered plumes of water vapor erupting from cracks near its south pole, reaching hundreds of kilometers into space. These geysers contain salt, organic compounds, and microscopic ice grains, evidence of a liquid ocean beneath the crust. As the jets spray outward, they replenish Saturn's E-ring, linking the moon and its planet in a delicate exchange of water and light. Inside those frozen geysers, there may be the chemistry of life. Even smaller moons show strange complexity. Miranda, one of Uranus's 27 moons, appears torn apart and reassembled, its surface carved by cliffs that rise 20 kilometers high. It is a patchwork of terrains, a world shattered and rebuilt, like a cosmic scar made visible. Triton, Neptune's largest moon, orbits backward, a captured wanderer from the Kuiper belt. Its surface is so cold that nitrogen freezes solid, yet cryovolcanoes still erupt, spewing gas and ice into the void. Scientists believe Triton was once an independent dwarf planet before Neptune's gravity claimed it, turning it into a frozen companion that slowly spirals inward. Among Saturn's moons, one stands apart: Titan, the great world of methane. With a dense orange atmosphere thicker than Earth's, Titan is a place both alien and strangely familiar. It rains liquid methane, forming rivers and lakes that glisten beneath the clouds. Winds sculpt dunes of organic dust across its surface. Beneath its icy crust may lie another hidden ocean, one of water and ammonia, warmed by the pull of Saturn's gravity. Standing there, you could almost feel at home. The air is too cold to breathe, but the landscape looks eerily like Earth, familiar yet distant, as if you were dreaming of home from another star. Further inward lies our own moon Luna, the first and closest companion we've ever known. Compared to the moons of the outer planets, it is simple, silent, and old. But to us, it means everything. Its gravity pulls the oceans, creating tides that have shaped life on Earth for billions of years. Its slow drift, away about 4 centimeters per year, lengthens our days and softens our seasons. Every eclipse, every reflection on the sea, is part of that ongoing cosmic relationship. The moon's craters record the violence of early creation, and its calm glow steadies the rhythm of our nights. The moon is also a storyteller. Its surface, unprotected by air or weather, preserves every impact, every footprint. When the Apollo astronauts walked there, their marks became part of that eternal record. Those prints will remain for millions of years untouched, unbroken, and waiting for whoever follows. The moon is Earth's archive, its mirror, its memory. Across the solar system, moons whisper stories of gravity and time of capture, creation, and survival. Some formed beside their planets, born from the same swirling clouds of dust and gas. Others were captured later, stolen from space and bound into orbit. A few were carved from their parent worlds in moments of violence like our moon, born from a colossal impact that tore molten rock into space. Every moon is a chapter, and every orbit is a sentence in the cosmic script. If you could drift among them, you would see worlds of ice and fire, of motion and stillness, of storms and silence. You would see proof that life, or the potential for it, is not limited to one place. Oceans exist beneath ice. Heat stirs within stone. Even in the coldest shadows, energy persists. The universe, it seems, refuses to leave any world entirely empty. Every moon moves, every orbit hums, every grain of dust tells a story. Together, They form a symphony, quiet, vast, and endless. So tonight, as you rest beneath Earth's moon, remember that you are part of a family far larger than you can see. You share this solar system not just with planets, but with hundreds of smaller worlds, each turning faithfully around its parent, just as we all turn around the Sunday. And beyond those orbits, waiting in the dark, are still more moons yet to be found. Small reflections waiting to be named, to be seen, to be remembered. The moons fade behind us now, and the journey turns inward toward the realm of ice and fire, of contrast and paradox. Few places embody that balance more perfectly than Mercury, the smallest planet, and the one closest to the Sunday. It is a world of extremes, where heat and cold coexist, and where silence has reigned for billions of years. Mercury rushes around the Sun at tremendous speed, completing a full orbit in just 88 Earth days. Yet, it spins so slowly on its axis that one Mercury day from sunrise to sunrise lasts 176 Earth days. This strange rhythm means that a single day here is twice as long as a year. While one side bakes under relentless sunlight, the other side freezes in eternal night. The temperature swings are among the most violent in the solar system, from 430 degrees Celsius in the day to negative 180 degrees Celsius at night. Standing on its surface would feel like standing in a vast desert of stone and silence. The sky is black even at noon, for Mercury has almost no atmosphere to scatter sunlight. The sun would hang immense in the sky, more than twice as large as seen from Earth. Its light so bright it would turn shadows razor sharp. Yet beyond the horizon, stars would still gleam, undimmed by air. It is a world of clarity, harsh, perfect, unforgiving. The planet's surface tells the story of ancient violence. Craters overlap like scars, relics from a time when space was chaotic and collisions frequent. The largest of these, Solar Basin, spans 1,500 kilometers, the result of an impact so powerful that it caused ripples on the opposite side of the planet, raising mountains and ridges like frozen waves. Around it lie plains of cooled lava, evidence that once, long ago, Mercury's interior was molten and alive. Though the planet is small, its core is enormous, making up nearly 80% of its radius. It is an iron heart, heavy, dense, and metallic, a remnant of the planet's violent youth. Some scientists believe Mercury was once larger, with a thick, rocky mantle, until a colossal collision stripped it away. What remains today is the exposed core of that lost world, spinning quietly through sunlight. This metallic core generates a faint magnetic field, unique among the inner planets besides Earth. It's weak, just 1% the strength of our own, but still enough to interact with the solar wind. As particles stream from the sun, they bend around Mercury's invisible shield, creating small, shimmering auroras, not of color and light as on Earth, but of pure magnetism. These invisible curtains of energy ripple across its magnetic poles, unseen but enduring. Despite its proximity to the sun, Mercury also holds something profoundly unexpected: ice. At its poles, deep inside craters that never see daylight, temperatures are so cold that water brought by ancient comets remains frozen. The Messenger spacecraft confirmed this in 2012. Bright reflections of radar light bouncing off the frozen deposits, hidden in permanent shadow. The contrast is breathtaking, solid ice surviving within a world bathed in flame. Mercury's exosphere, an almost non-existent atmosphere, is made of atoms knocked loose from the surface by solar wind and micrometeorite impacts. Sodium, potassium, and oxygen drift upward and escape into space. They form a ghostly halo around the planet, invisible to the eye but glowing faintly under ultraviolet light. Each atom exists only briefly before vanishing, replaced by new ones blasted from the ground. It's not an atmosphere in the way we understand it, more like a constant whisper of renewal, fragile as dust in sunlight. Because Mercury's rotation is locked in a 3-to-2 resonance with its orbit, the same regions face the Sun in a predictable cycle. This means that the craters at the poles, untouched by light, have remained frozen for billions of years, while the equator endures unending cycles of scorching and freezing. The planet's extremes are not random, they are mathematical, governed by gravity and rhythm, like music written in heat and shadow. To the human eye, Mercury may seem lifeless, but its silence holds a kind of perfection. Every crater, ridge, and plain preserves the memory of the solar system's earliest days. Unlike Earth, there is no erosion, no wind, no rain, nothing to erase the past. The surface is a fossil, a record untouched by time. When we look at Mercury, we look directly into history, unchanged since creation. In 1974, Mariner 10 became the first spacecraft to visit Mercury, revealing a world both familiar and alien gray like the Moon, yet shining like steel. Decades later, Messenger returned to map the planet in detail, uncovering unexpected colors, magnetic fields, and traces of ancient volcanic plains. And soon, a new mission, Bepi Colombo, will arrive to continue the story, to measure its interior, its magnetic field, and the way sunlight shapes its surface. Even the smallest planet has something to teach, that endurance itself can be a form of brilliance. At the outer edge of the solar system, sunlight weakens into a whisper. The stars begin to dominate the sky, and the worlds that circle here move slowly, quietly, through eternity. Among them drifts Neptune, the farthest known planet, a deep blue sentinel in the dark. Though it receives barely 1/1000th of the sunlight that reaches Earth, Neptune is anything but cold in spirit. Beneath its sapphire clouds lies energy, motion, and mystery beyond imagination. Discovered not by sight but by mathematics, Neptune is a triumph of human curiosity. In the mid-1800s, astronomers noticed that Uranus was not moving exactly as predicted. Something unseen was tugging at it, a presence hidden in the void. Two mathematicians, working separately, calculated where that invisible object must be. When telescopes turned toward the predicted point, Neptune was there, waiting, the first planet found through reason alone. It was a moment when thought reached further than vision. From a distance, Neptune seems calm, wrapped in layers of blue. But beneath that tranquil glow rages one of the most violent atmospheres in the solar system. Winds tear across its surface at 2,100 kilometers per hour, faster than the speed of sound on Earth. Great storms swirl through the methane-rich clouds, forming dark ovals larger than our entire planet. The most famous, the Great Dark Spot, was discovered by Voyager 2 inches, 1,989, then vanished years later, only for another to appear in its place. Even here, at the edge of sunlight, motion never ends. Neptune's color comes from methane, which absorbs red light and reflects blue. But the depth of its hue remains unexplained. Some secret interplay of chemistry and scattering that gives it a vibrancy unmatched by any other planet. Its upper atmosphere shimmers with thin hazes, while deeper layers hide clouds of hydrogen, helium, and ice. Lightning flashes within these unseen depths, brief sparks of energy illuminating storms that rage for decades. Despite being so far from the Sun, Neptune emits 2.6 times more heat than it receives. Like Jupiter and Saturn, it glows faintly with the leftover warmth of its formation, a memory of gravity compressed into heat. That inner fire may also come from slow contraction or radioactive decay deep inside. Whatever its source, it keeps Neptune alive. Its storms churning with inexplicable vitality in the frozen dark, Orbiting this blue giant is a small collection of moons, 14 known so far, each one a fragment of story and time. The largest, Triton, is unique among large moons. It orbits backward, in the opposite direction of Neptune's rotation. This retrograde motion suggests that Triton was once an independent world, likely a dwarf planet captured from the Kuiper belt long ago. The capture must have been catastrophic, disrupting any earlier moons Neptune may have had. Triton's surface is a frozen tapestry of nitrogen, ice, and methane frost. It reflects sunlight with a pale sheen, but beneath that icy stillness lies activity. When Voyager 2 passed by, it saw cryovolcanoes, plumes of nitrogen, gas, and dust erupting hundreds of meters into the air, powered by the faint warmth of the Sunday. Triton, it seems, is not dead, but dreaming its surface, shifting subtly with the rhythm of its orbit. Beneath the crust, there may even be a subsurface ocean, locked beneath kilometers of frozen nitrogen, warmed by internal tides. Neptune itself is encircled by a delicate system of rings, thin and incomplete. Unlike Saturn's broad bands, Neptune's rings appear broken arcs of dust and ice that shimmer only in scattered light. They are maintained by small shepherd moons, whose gravity keeps the particles from drifting apart. These rings are temporary, fragile. They will eventually fade, lost to the planet's pull. Yet for now, they remain, glowing faintly like brushstrokes on a dark canvas. Voyager 2 is the only spacecraft ever to visit Neptune. When it flew past in August 1989, it revealed a world alive with storms, moons, and winds that defied expectation. From that encounter came images of deep azure swirls, bright methane clouds, and Triton's geysers spraying across the void. Since then, no probe has returned. Neptune has remained alone, silent, waiting. But new missions are being dreamed of, orbiters and flybys that may one day unveil its hidden heart and the mysteries of its interior. The planet's gravity extends far into space, marking the edge of the solar system's planetary domain. Beyond Neptune lies the Kuiper belt, a vast ring of icy remnants, dwarf planets, comets, and frozen debris left from creation. It is a bridge between our solar system and the interstellar dark beyond. Neptune's gravity sculpts this region, keeping its objects in check, guiding their slow dance around the Sunday. It is both a boundary and a guardian, a silent sentinel that watches the frontier. Neptune is a paradox, distant but dynamic, cold but alive. It shows us that energy is not bound by light, that motion can exist even in shadow. It whispers of unseen processes, of worlds that glow without warmth, of storms that rage in silence. If you could float above Neptune's clouds, you would see twilight in every direction. The sun would be a bright star, its rays scattering weakly through blue haze. The horizon would curve endlessly, and the winds, invisible but relentless, would move beneath you like waves. Every gust would be an echo of heat, every spark a trace of time. And if you listened, you might almost hear the hum of that distant planet, the soft, slow breathing of a world that remembers its own creation. Even in the farthest dark, Neptune reminds us, stillness is never truly still, and silence is never truly empty. Beyond Neptune's blue storms lies a place where light fades into the threshold of infinity, the Kuiper belt, a realm of frozen relics orbiting in quiet procession around the Sunday. Here, the solar system ends not with a wall, but with a whisper, a gradual fading of order into cosmic dusk. It is a region of countless icy bodies, ancient and untouched, drifting through silence for billions of years. These are the leftovers of creation, the fragments that never became planets, each one carrying the memory of the solar system's birth. The Kuiper belt stretches from about 30 to 55 astronomical units from the Sun, billions of kilometers beyond Neptune. Within this immense expanse are dwarf planets like Pluto, Haumea, Makemake, and Eris, along with smaller icy bodies known as Kuiper belt objects, or KBOs. Some of them follow stable, circular orbits, while others travel in eccentric paths tilted high above the plane of the planets. Together, they form a halo of frozen time, circling the Sun in near-perfect silence. If you could travel here, the Sun would no longer warm your face. It would appear as a brilliant star in a black sky. Its light weak but still steady. The temperature hovers around -230 degrees Celsius, cold enough to freeze nitrogen solid. Every object here glimmers faintly with the light of distant creation. Ice, rock, and methane blend into surfaces of pale red and blue, polished by eons of cosmic frost. Among these drifting worlds, Eris stands as one of the most distant and massive. Slightly smaller than Pluto but denser, it lies nearly 3 times farther from the Sunday. When it was discovered in 2005, Eris challenged the very definition of what a planet is. Its existence led astronomers to reclassify Pluto and define a new category: dwarf planet. Eris reflects nearly all the sunlight that touches it, making it one of the brightest objects in the outer solar system. Its surface, composed of frozen methane and nitrogen, gleams like polished glass in the darkness. It orbits the Sun once every 557 Earth years, completing its vast circuit through shadow and silence. Close to Eris drifts Haumea, a world unlike any other. It spins so fast, one rotation every 4 hours, that it has stretched itself into the shape of an elongated ellipsoid, like an egg in motion. Its rapid spin gives it a dazzling ring system and 2 moons, Hi'iaka and Namaka, named from Hawaiian mythology. Haumea's surface is coated in crystalline water ice, evidence of a recent collision that may have shattered it long ago. Even here, on the edge of light, energy has left its mark. Then there is Makemake, a smaller, reddish world that moves gracefully through the Kuiper belt. It has a thin layer of methane ice, and beneath it, possibly nitrogen that evaporates and condenses as it circles the Sunday. A tiny moon, discovered only recently, follows it invisible to most telescopes, yet faithful in its orbit. Each of these dwarf planets, though frozen and far, plays its part in the slow, gravitational choreography of the outer system. But not all objects here are orderly. Beyond the Kuiper belt lies a more mysterious realm. The scattered disk, home to bodies flung into wide, irregular orbits by Neptune's gravity. Some venture thousands of astronomical units from the Sun, wandering for millennia before returning. These are the potential birthplaces of long-period comets, icy travelers that, when perturbed, fall inward toward the Sun, briefly igniting into tails of fire before vanishing again into the dark. Each comet is a messenger from the frontier, carrying the oldest material in existence, ice and dust unchanged since the dawn of time. The farther you travel, the thinner the solar system becomes. Eventually, you reach a place where the Sun's gravity grows weak. The Oort cloud, a hypothetical sphere of icy bodies stretching perhaps a light year from the Sunday. No one has seen it directly, but its presence is felt in the paths of comets that return after tens of thousands of years. It marks the true boundary between our solar system and interstellar space, the final breath of the Sun's reach. Every so often, a passing star or the tidal pull of the Milky Way disturbs one of these frozen wanderers, sending it tumbling inward. Some disintegrate near the Sun, their fragments scattering light across the sky as shooting stars. Others survive, looping back into the abyss. These travelers remind us that the solar system is not closed. It breathes. exchanging matter with the galaxy beyond. If you could drift here between Eris, Haumea, and Make, you would find serenity beyond comprehension. The darkness would not be empty, but filled with faint light, the glow of distant stars, the faint blue dot of Neptune far behind you, and the sun, a single steady point that still commands everything you see. Time here has little meaning. Days and years blend together into slow eternity. It is from this distant realm that Voyager 1 and Voyager 2 now travel spacecraft born of human curiosity, carrying messages from our world to the unknown. Their signals still reach us, faint and delayed, crossing billions of kilometers through interstellar night. Each carries a golden record, sounds, images, and greetings in dozens of languages, a time capsule of Earth's story sent into infinity. Somewhere, beyond the Kuiper Belt, those voices continue to drift. The Kuiper Belt reminds us that endings are rarely final. Beyond every boundary lies another beginning, another layer of wonder waiting in the dark. These frozen remnants of the solar system's youth are not dead, they are waiting, preserving the building blocks of creation for whatever comes next. As you rest tonight, imagine looking outward from that frontier, a horizon where the sun is small, the stars are infinite, and silence has weight. In that stillness, you might understand the true nature of the cosmos, not an emptiness to fear, but a vastness to belong to. Good night, and see you in the next video.